Okay, so we are going to continue on with 6.5 properties of log. So all the log rules that we used here, we're going to be using more of them and mixing them up. That's pretty much what we're doing. There's not any new properties. We're just using them all together. So example one, we want to go ahead and simplify as much as possible. So first thing I noticed, they're both log base 10. So since I'm adding here, I can go ahead and take 50 and the 2. That's really going to be multiplying. So 50 times 2 is 100. So now I'm asking 10 to what power is 100, right? Because if you converted that, which you do not have to, because a lot of us should be being able to do this a little bit quicker. This is the same thing as saying 10 to what power is 100? And that answer would be 2. 10 squared is 100. So what's my exponent is 2. Part B, I'm going to first work on simplifying the log base 5s, okay? So simplify here first. So they're both log base 5. And since I am subtracting, that's really going to be dividing between there. So it's really 3/9. And if I simplify that, that's really 1/3. And then I'm going to use my other rule since I have 5 being raised to log to the base 5. Those cancel. So my final answer here is simply just a 1/3. Part C, I'm going to go ahead and simplify here. The cubed root of 125 is 5. So that's something you should just know. And then notice, since it's a log base 5 of 5, that's just going to equal 1. That was our first rule. All right, we're just cruising along here. Oh, I missed these side problems. So let's go back and take a look at the second problem of part A. Once again here, notice we have the same base, log base 3. We are subtracting. So when you're subtracting, that means we're going to go ahead and divide. 54 divided by 2 is 27. And then I'm asking myself, I can simplify this now. I don't want to just condense it. I'm saying 3 to what power is 27? And the answer is 3. 3 to the third power is 27. So that's your answer. That second one below it, once again, I'm going to first simplify this because I'm noticing they both have log 4. So what I'm doing here, because I am adding, that means between the 2 and the 32, I can multiply them. 2 times 32 is 64. And then just like the rule before, 4 to the log 4th cancels. So literally my answer is just 64. All right, I'm going to go back down to part C. So again, I'm going to try to simplify this one. So log base 2, I'm kind of stuck. The 5th root of 16, I don't know what that is, but I'm going to go ahead and put this in, instead of root form, I'm going to put this into an exponent form. So this is the same as saying 16 is 2 to the 4th power. And then remember how we did exponents, flower power, it's the power over the root, so the 5th root. So it's going to turn into 4/5. So now we have log base 2 of 2. So using what we did before, the log base 2 of 2 cancels, and your answer is simply 4/5. Again, why is it 4/5 if you're having a tough time? Go ahead and go back to exponential form. This is saying 2 to what power equals 2 to the 4/5. And notice, obviously, it has to be 4/5. So again, that's why it cancels. So if you're ever getting stuck, just go back to converting to exponential. All right, next one, same idea here. I'm going to turn it into flower power form. So this is e to the 7/5. And then once again, the natural log and the e will cancel. And that's going to give me 7/5. Again, why does it cancel? If you need to, turn it into exponential form in your mind, because this is saying e to what power is e to the 7/5? Well, it has to be 7/5 then. So if you want to convert it, you can, and it should tell you what your answer is. All right, this next one, we want to go ahead and simplify. So I'm starting to notice what operations. First of all, they are not the same base. Very, very important here that you notice that this is log base 3 and this is log base 7. Totally different. So I am going to go ahead and use my rule from the change of base formula that we've talked about. That was the last rule we learned. I know to do that because I have different bases. So the change of base formula, which we're going to use on all three of the problems, means I'm going to go ahead and take log of 3 or log base 3 of 7, and I turn that into log 7 divided by log 3. And then the second portion here, so this thing, I did the change of base and got this. I'm going to go ahead and change the second portion as well. That's going to be log 9 over log 7. So again, it's just the large number over the small number, the base number at the bottom. Now you should notice something here. When you have the same thing on the top and the bottom, they cancel. So now I really just have log 9 divided by log 3. And now I can use the change of base formula backwards, which means my small number is the bottom one and my large number is the 9. So log base 3 of 9 is your final answer for this one. Oh, and I'm just thinking to myself, looking at those numbers, I can simplify that more. So yes, that is correct, but there is one more step once I looked at that, because I can say 3 to what power is 9, because again, that's what it's asking you. What is the exponent? 3 to what power is 9? And the final answer is 2. I can simplify that one. All right, I'm going to go ahead and change colors here. So same idea for the second one. I'm going to go ahead and simplify each one. So I've got log of 13 over log of 2. Again, I'm using the change of base formula because my bases are different. That should be the key to you. I have a base 2 and a base 13, so you can't use any of the rules that we used before. But once again, we set the problems up very nicely for you so that something cancels. Log 13s are going to go ahead and cancel here, which is going to give us log 32 over log 2. Just like the last problem, I'm going to go ahead and convert that into one log. So remember that little 2, or that 2 is going to be the little 2, and the top number is a large. And then I'm going to convert it one more time. I'm saying 2 to what power is 32? Again, if you need to write that step out, I keep kind of writing it in red. Go for it, but you don't have to write the step out. 2 to what power? And that is to the 5th. All right, let's go ahead and do one more. So once again, I'm noticing I have different bases, 4 and 5. So I'm going to do exactly the same thing. I'm going to go ahead and do my change of base formula. So log 5 over log 4 times log 64 to the x over log of 5. Once again, we purposely set it up this way for you where there should be something that cancels, and it does. And then that simplifies to log 64x over log 4. Once again, I'm going to go ahead and convert it into one log. The bottom number is the small one. The top number is 64 to the x. And then I am going to go ahead and convert this because I feel like I'm kind of stuck. So I'm going to go ahead and convert this. This is saying 4 to what power equals 64 to the x. But since they already have an x, I'm actually not going to use an x here. I'm going to use just a box. So this is saying 4 to what power equals 64 to the x. Well, I know 64 is the same thing as saying 4 cubed. So that means that box has to be equal to 3x. Okay, so let's continue on. Write the expression as a sum or difference of logs. Express the powers as factors. Okay, so what I'm noticing in this one is I'm multiplying. So if I'm multiplying and I want to expand it, it also uses the word expand here. I'm going to write it as 2 different logs. So log base 5 of 25 plus log base 5 of x. Again, I'm expanding. Log base 5 of 25, I can simplify. It's saying 5 to what power is 25? That's 2. And I can't simplify the second part because of the x in there. So this is done. Next one, instead of using log, we're just using natural log. That's okay. We're dividing, which means if I want to expand it, I'm going to turn that into subtraction. Something interesting happened here is, remember, the natural log of e, just like we did in the problems above, cancel. And that's going to leave me with the natural log x minus 8 minus the 2x comes down. Again, that's like saying e to what power equals e to the 2x, so it's just 2x. This one might look confusing, but break it down like you normally would. So this is saying log x is on top plus the other part on top is x plus 3. It's on the bottom, you subtract. So then we're going to say minus log x plus 5 to the 8th. And then something very important. It says express powers as factors. That's what it says there. So I'm going to go ahead and take this 8 and I'm going to swing it to the front. Because again, you could put that 8 power and make it a times 8 in the front. So then this is going to go ahead and simplify to log x plus log x plus 3. I'm going to bring the 8 to the front, minus 8 log x plus 5. I'm trying to look at each log. None of them are going to be able to simplify. That's my answer. Again, it says write the expressions as a sum or difference of logarithms. So we're expanding it. We are making it bigger, and that's what we did. Okay, example 3, it wants us to go ahead and condense, write as a single logarithm. Okay, so we want one log. These both have log 3. So that's important to note. Using the rule I talked about before, when that number is in the front there, you can go ahead and swing it to be an exponent. So same here, we can go ahead and swing this 5 to be an exponent. So what that gives us is log base 3 of u to the 6th plus log base 3 of v to the 5th. And then I know because I'm adding, I can go ahead and take the u to the 6th and v to the 5th to condense it into one log. That is multiplying. So it's going to be u to the 6th times v to the 5th. Done. I condensed it into a single logarithm. That's the goal. Same thing with part B. I don't have any numbers in the front, so I can literally just go ahead and, since it's subtracting this time, excuse me, I can go ahead and divide these. And we can keep it like that. That is fine. Done. All right, part C has a lot more going on, so take it piece by piece. Start with swinging those exponents. Okay, so log base A of 7x to the 6th cubed minus log base A 5x plus 19 to the 1/8. So I can actually simplify because it's power to power here. So I can do 7 cubed, and 7 cubed is going to be, and you can use a calculator. I would not have that one memorized. It's 343. My exponents I multiply. 6 times 3 is 21 minus log A. Now you can either keep this exponential, or sometimes you're going to see it being turned into a radical. Either way is fine, but I just want to show you the radical. It's the same thing because it's flower power. The power is 1, the root is 8. Now I still have one more step to do because I'm subtracting. I can go ahead and condense this into 1 log base A. Those are the two things I'm going to end up dividing. So again, because we're subtracting there, I can condense it into 1 log A with 343x to the 21st on top, all over the 8th root of 5x plus 19. Done. I've written it as a single logarithm, just like it asked. All right, let's keep rolling. Example 4, rewrite expressions in variable terms. So it says, given that log base 7 of 2 equals a, so I'm going to be looking for this, and log base 7 of 3 equals b, express the following in terms of a and or b. Right now I have log base 7. Oh, good, but it's of 6. So can I manipulate the number 6? I want to somehow try to get it to be something to do with 2s and 3s. Yes, you can, because I know 6 is the same thing as saying 2 times 3. So notice that these line up now. So there's my 2, and there's my 3. So I'm purposely using those numbers. I'm trying to find things of 2s and 3s. Those are my magic numbers for this problem because they told me so. So I'm changing the 6 into 2 times 3, and since it's multiplying, I can expand it into addition. Okay, so once again, I've got my 2 and my 3 here, very important. Okay, so what we can go ahead and see now is log base 7 of 2. Let me erase that. Notice that this entire thing is this entire piece there. They're exactly the same. So I can replace that with an A. Plus, notice log base 7 of 3 is the same as this. So since it's exactly the same, I can replace it with a B because it says write it in terms of A and B. So your final answer is A plus B. All right, part B, same thing. I want to somehow turn that 8 into something with 2s and 3s. That's my goal. Those are my magic numbers there. I know that 8 is the same thing as saying 2 to the 3rd power. So I went ahead and I figured out how to manipulate it into the 2 and the 3. Now I'm going to use my rules to expand it. The first thing I can do is I can go ahead and take that 3 exponent and flip it to the front. And I'm noticing, oh, look at this. Once again, log base 7 of 2 is exactly what this says, log base 7 of 2. So I can replace log base 7 of 2 with an A. So I'm going to go ahead and say equals 3. I'm replacing that with an A, and that's my final answer. Okay, part C, again, I've got 4 and 27, but I want to write it in terms of my magic numbers, 2 and 3. Those are the numbers that I want to change it to, just those numbers. So I know on the top, for instance, that's the same thing as saying 2 squared, and the 27 is the same thing as saying 3 cubed, right? Okay, perfect. 2s and 3s, that's what we were talking about. Because it's division, I can go ahead and expand it. I can say log base 7 of 2 squared minus, because division turns into minus when I'm expanding it, log base 7 of 3 cubed. Okay, there's still more that I can do because now I can go ahead and swing my exponents out in the front here. So this is going to be 2 log base 7 of 2 minus 3 log base 7 of 3. Again, notice this right here, log base 7 of 2, matches up with log base 7 of 2. So I'm going to go ahead and replace that with an A minus, and then I'm noticing very nicely that log base 7 of 3 matches up with log base 7 of 3. So I can write that as minus 3b because I can replace the log base 7 of 3 with a b. And that is simplified. Now it's in terms of a and b, or b, just like it asked. Okay, the next example is really just the same thing. So for time purposes, I'm going to go ahead and skip. But if you would like to, this is just extra practice. So if you want to do it and get your answers checked by me, great. Let's go ahead and do example 5. So express y as a function of x. The constant c is a positive number. Okay, so what we're trying to do is when it says express y as a function of x, we're pretty much just solve for y. That's what we're trying to do when it says that. So solve for y. So right now we don't have y alone. We have the natural log of y. So we're going to have to use some of our rules to manipulate it. So it's always the same 6 rules. We're just using them differently each time. Notice for this problem that we're adding, which means the 6x and the c can be multiplied. Constants usually go in the front. So I'm going to go ahead and write this as c times 6x. But yes, that is the same thing as 6x times c. Okay. So again, I condensed those 2 natural logs into 1 natural log by turning the adding into multiplying. And then when I have natural log on both sides like this, and there's nothing else, I can cancel out the natural logs, and I'm simply left with y equals c times 6x. Or again, if you said 6x times c, that would be the same thing. Done, because again, the whole goal is to solve for y. Let's go ahead and take a look at part B. Okay, the difference between A and B, you cannot cancel out the natural logs. I see people try to do that. You can't do that because there's a negative 5x here that doesn't have a natural log. That is a problem. So we have to go about it differently. Now we can put a natural log e in front of it because if you recall, let me write it down first so it looks nice and I have enough room. So what I've just added in is this part here. So I added in the natural log e and raised it to the negative 5x. And there's a reason why I did that, okay? And you're allowed to do that. So I'm gonna put a little thought bubble here. Because remember, natural log e to the negative 5x, we have a rule. That's like saying e to what power equals e to the negative 5x. The natural log and the e cancels, and that is equal to negative 5x. So I didn't change it because natural log e to the negative 5x is negative 5x. So it's okay that I went ahead and did that. I didn't change the problem. I did that so that I can get them all to be natural logs, because now I want to get 1 natural log on the right side. So my goal is to get 1 natural log on the left side and 1 natural log on the right side. So I'm going to condense because I am adding here. I can go ahead and take my 2 pieces and turn that into multiplication. So that is now going to turn into e to the negative 5x times c, or I can put the c in the front, which I like to do, c times e to the negative 5x. Now that I have 1 natural log isolated on each side, I can go ahead and cancel them, which leaves me with y minus 3 equals c times e to the negative 5x. Again, I'm trying to get y alone. So all I have to do from here is add 3 over, and I'm done. I have now solved for y. All right, so let's keep rolling. Go ahead, and I'm actually going to have you try part C. So I'm going to say stop, and I'd like you to solve for y. Okay, so for this one, notice that they're all log base 2. So I'm first going to condense the left side, log base 2. Since I'm adding here, that means that y and that 3 I can turn into multiplication. That's 3y. Now that I have log base 2 isolated on each side, the log base 2's can cancel. So that's going to give me 3y is equal to c. I'm going to go ahead and solve for y by dividing by 3 to each side. So my equation is y equals c over 3. So that's the easier one to do. That's like A. A and C are very similar. D is the hard one, so I'm going to go ahead and do this one with you. So once again, the problem here is the 9x doesn't have a log base 3. We need to put a log base 3 there, right? Because this one has it and this one has it. We need this one to have it as well. So we first have to when you add in the log base 3, you're going to be adding in log base 3 of 3, because that's really just 1, to the 9x, and that would just bring, remember, these would cancel, and that equals just 9x. So we're not actually changing the problem, we're just making it look different. Minus, and I'm going to recopy this down. Okay, the reason why we do that is because we want to isolate one log on each side, one log base 3 on each side. So now that these are both log base 3 and log base 3, and they're connected by subtraction, I'm going to take this divided by this. So that's going to turn into 3 to the 9x divided by c. Yay, you know what's exciting? We have one log base 3 isolated on each side. So gone, gone. Beautiful. So we have y plus 4 equals 3 to the 9x over c. Again, I want to get y alone, so my last step is to go ahead and subtract 4 from each side. And now I have y all alone. Or you can sub the y, you can put f of x in if you'd like. All right, so that is it for the notes, and I will see you in class for more practice.